Today we're going to work with different kinds of exponents and their rules. There are quite a few, but the more that you work with these properties, then the easier it will become to utilize. So I'm going to start explaining what these properties are. No, you don't have to remember the exact names of them, but you just need to know how they work. So the first one is product of powers property. So basically you're going to see examples that look like this. You're going to have x to the third times x to the seventh, okay? So as long as they have the same base, all you do is add the exponents, and that is your answer. So when we add the exponents, this becomes x to the this becomes x to the 10th power, and that is it. Now, if we had something like y to the second power times x to the third, since they do not have the same base, you would keep it as y to the second, x to the third, because they do not have the same base to combine them together. So that's the product of powers property. The quotient of powers property is basically the exact opposite. So instead of multiplying with the same base, you're going to have to divide. So if we have x to the 10th power divided by x to the 5th power, all you're going to do is subtract the exponents. So when you subtract the exponents, this becomes x to the 5th power. And again, they have to have the same base. And that's what you got. You subtract the top from the bottom. The last is the power of a power property. So you might see something like this. So x squared, and then we're going to have it also to another power of 7. So that's the power of the power. The 7th power to the 2nd power to the 7th power. So what you're going to do here is you're going to multiply the exponents. You're going to think about this. It's like the distributive property. You just multiply it to whatever's inside. So this becomes x to the 14th power, and that's your answer. Now, you also might have something like this as an example. You might have 2x to the 3rd power to the 6th power. So this means you are going to distribute the 6 exponent over to the 2 and the 3. Now, if 2 does not have an exponent, it's always to the 1st power. And we're not multiplying 6 to 2, we're multiplying the 6 exponent to the other exponents. So your answer ends up becoming 2 to the 6th power times x to the 18th power, because you're multiplying. And later on, I'll probably ask for you to simplify 2 to the 6th power, which is 2 times itself 6 times. But right now, that's just going to suffice. Now we're going to use this to start our exponent examples. So if they have the same base and they're multiplying, you are going to use the first property. You're going to add the exponent. So this becomes 3 to the 8th power. Now, to find 3 to the 8th power, you would multiply it by itself, or you can use your calculator to fix that. But your full answer is 6,561. Now, the next one, we have the same situation. We are multiplying with the same base, so we're adding our exponents. This becomes 10 to the negative 2nd power. Now, I'm going to explain this later in the video, but this makes you, to get rid of the negative exponent, we flip it, so it becomes 1 over 10 to the positive 2nd power, which is 1 over 100. Now, if you did that up in your calculator, you would also get, it's 1/100th, so it would also be the decimal of 0.01. Go ahead, and now we'll do the next one. So when we go ahead and add these exponents together, we get x to the 0 power. Now, anything to the 0 power is 1. Not the exponent, the entire entity is 1. So that is your answer right there. Go ahead and use the other properties for these next problems. Check back and see if your answers are correct. All right, these are the answers you should have received. Just so you know, if you're putting some exponents in your calculators, when there is a parenthesis, make sure you utilize that parenthesis. So this parenthesis helped us get our final answer. Now in this third example, there is no parenthesis, so what you would do is you would do 5 to the 4th power and then tuck that answer in the front later on. So those are your answers. Make sure you double check them. Now we have 3 more exponent properties to cover. There's a lot in this chapter. So let me go ahead and do some examples. The first one is power of a product property. So basically, all you're going to need to know is that you're going to distribute. So if you have, and I kind of showed you this earlier, if we had 2 to the third power x and then y to the second power, and we had these parentheses to the fifth power, you are going to distribute this and multiply it. So you're going to multiply it to the exponents. Now, we talked about this earlier. If x does not have an exponent, it's really 1. And you're just going to distribute that 5 to only the exponents, not the bases. So your answer would be 2 to the 15th power, x to the 5th, y to the 10th power. And that's what you got. Now, the power of a quotient property is the same. You also distribute here, okay? So when you're dealing with quotients, that's when you're going to have something like, okay, so we have x over 2 to the 4th power. And if we have all of that to the 7th power, again, you distribute it. So you have it going to the x exponent, which is 1, because it's not there, and then to that 4, and you're going to multiply. So we end up having x to the 7th power over 2 to the 28th power, and that's how that would work as well. Now the negative exponents. I've kind of mentioned this in the past, but what you do is you flip the fraction. So if we had something, I'm going to put this in a whole different color so it stands out. If we had x to the negative 2nd power, to get rid of that x, or the negative sign, you're going to make it into a fraction, which you put it over 1, and you flip whatever has the negative exponent with it. So it's going to turn into 1 over x to the 2nd power, and that gets rid of the negative. It also happens if it's on the bottom of the fraction, the denominator. So if we had x to the 4th over 2 to the negative 3rd power, all you do is only the thing with the negative exponent flips. So that x to the 4th power is staying where it is because it does not have a negative exponent. So it'd be x to the 4th times 2 to the positive 3rd power, and that would be your answer. So let's go ahead and try these examples together. So we are going to distribute this exponent to both of these numbers. Now we have to multiply the 2 to the exponents only. Both of them only have a 1 as an exponent, so it becomes negative 1.5 to the 2nd power and then y to the 2nd power. Now to simplify it even more, because that's really what I want you guys to do, we're going to simplify negative 1.5 to the 2nd power, which is 2.25, and then we bring down the y squared and we're done. The next one is the same, so we go ahead and distribute it. So we now have 10 to the negative 3rd power and y to the negative 3rd power. Now we have these negatives going on, so we are going to move both the 10 and the y, and we're going to flip it to get rid of our negative signs. So now we have 1 over 10 to the 3rd power, y to the 3rd power. The action of flipping the fraction gets rid of that negative. I'm going to simplify a little bit even more. And so what we're going to have is 10 to the 3rd power, which is 1,000. So this becomes 1 over 1,000 y to the 3rd. And that's, y to the 3rd. And that's our answer. And then the last one is going to just be distributing again. So we have w to the 4th power over 4 to the 4th power, which I'm going to simplify that. And it becomes w to the 4th power, man, it's messy, over 256, and that is your final answer. Go ahead and try the next 6 on your own. These are a little more complicated, especially at the bottom. Just try your best and check back to see if your answers are correct. All right, so these are your answers. Don't forget that, especially like in the first and the second problems, that I had these parentheses around that 10, so that creates a negative answer. Also, same with the negative 4. I put that in my calculator with parentheses. Then we had a couple negatives. So then what happened here, I tried to show you in orange that I flipped both the numerator and the denominator because everything had a -5 exponent. So I did that. Same with the very last one. So if everything has negative exponents, you flip them. You only flip what has negative exponents. So now we have a word problem that we're going to use. It says the area of a rectangular computer chip is 111 times a to the third b to the second square microns. The width is 8 AB. What is the length? So I'm going to draw a picture. It helps me visualize a little bit. So we have that the width is 8 AB, and then the area is 111. A cubed b squared. So we just have to find the length. So to find the area, you do length times width. So if we had 111a cubed b squared equals our length times width, we have 8ab times our length, all we're going to have to do is now divide by 8ab to find what the length is. So right here, we're going to simplify. Let's look at this. We have an a with no exponents. That means there's a 1, same with the b. So I'm going to take these chunk by chunk. So watch me separate all of these. I'm going to now have a fraction of 111 over 8 times a cubed over a to the first times b squared over b to the first power. And I'm just going to simplify these guys. So 111 and 8 cannot be simplified. I'm going to keep it as an improper fraction. So in my final answer, I'll have 111 over 8. Now, we're going to bring back this division property where if we're dividing with the same base, we subtract the exponents. So it becomes a to the second power. And then the same thing here with b's exponents. So we subtract, so it's b to the first power, or you could just keep b by himself. And they are on top of the fraction. So that is what we have as the length, 111 times a squared b over 8. And it is microns. We want to label our answers always. And that's your answer.